Okay. Ngayon naman, let's have some examples yung sa computations na ginagawa natin when we are dealing with timers with our microcontrollers. So, actually, most of the questions, yun, meron tayong general flow ng ating solution. So, first is, ano ba yung time duration na kailangan natin? So, it can be a delay, it can be a period, or something na kailangan natin ma-generate out of our timer. And then, convert natin yung time duration na yun doon sa total ticks or clock cycles na kailangan natin given yung clock ng ating microcontroller. And then we compare this total number of ticks with the maximum period register value to get the value of the prescaler if we need to use a prescaler. Then, yun, pagkakuha ng prescaler na value, and then alam natin yung timer delay equation natin from the previous slide deck, we can get the period register to get the exact, or I guess the closest, or the period register value natin na makukuha natin yung target natin na time duration. So, first example, we want to generate a 5 hertz na square wave na 50 hertz of duty cycle, square wave, with a 16-bit timer assuming a 4 megahertz clock. So, assume one cycle for rollover, tsaka meron tayong, yung available na lang na prescalers is 1s to 1, 1s to 8, 1s to 64, tsaka 1s to 256. So, yeah, most microcontrollers have limitations doon sa prescaler values na pwedeng gamitin. Fortunately for the STM32, alam ko medyo madami, wide range yung kanyang kayang gamitin na prescaler. So, ayun, as an exercise lang for this one, let's try to limit ourselves with these values. So, a 5 hertz square wave, that means 5 cycles per second. So, yung output natin, nag-change 10 times per second. So, ang kailangan natin i-generate na delay is, or yung output natin changes every 0.1 seconds. So, and ulit no. So, 5 cycles per second, nag-change yung output natin 10 times every second. So, yung output natin nag-change every 0.1 seconds. So, ayun, ang gagawin natin sa 0.1 seconds na yun. So, yung 0.1 seconds na yun, equal dapat siya sa number of cycles na gusto natin over yung clock frequency. So, 0.1 times 4 megahertz equals 400,000. So, compare natin si 400,000 with our maximum na period register, which is 16 bits. So, 2 to the 16 minus 1, that's 65,535. So, 65,535, compare that to 400,000, medyo maliit siya. So, we need a prescaler value. So, ang prescaler na gagamitin natin, or yung estimate natin, would be the number of clock ticks over yung maximum na period register value natin. So, makuha natin dito is 6. So, 400,000 over 65,000 is approximately 6. So, ano yung gagamitin natin na prescaler value? So, ayan, if we want to preserve yung ating accuracy or precision, more appropriately, if we want to preserve our precision, we want to use the lowest prescaler available na mag-fit yung period register natin. So that would be yung 8. So use prescaler of 8. So ayan, we have a prescaler of 8 and a clock frequency of 4 megahertz. And alam natin na yung t na kailangan natin dito sa equation is 0.1. We can solve for yung period register. Now, ayan, period register plus 1 kasi we assume 1 cycle for rollover. Then, isolates PR is t times f clock over ps minus 1. So, yung 0.1 seconds times 4 megahertz na clock over prescaler of 8 minus 1. That results to 49,999, which is less than 65,000. So, ayun. Alam na natin yung PR value natin, which is 49,999. and yung prescaler na value natin na 8. So usually yung dalawang values lang naman na ito yung kailangan natin whenever we want to configure our timer. Okay, example number 2, Morse code. So yeah, if familiar kayo sa Morse code, it's yung parang encoding na dots and dashes. Yung standard duration natin for a dot is 50 milliseconds at least. And yung standard dash is at least 3 dot durations or 150 milliseconds. So, determine the period register and prescaler values to be used for a 16-bit timer that can generate a dash with a clock of 6 megahertz. So, gusto natin mag-generate ng dash, which is 3 dot durations long, which is at least 50 milliseconds. So, yun, meron na tayong time period na kailangan natin, which is 150 milliseconds. So, to rephrase yung ating question, yan, determine yung PR and PS values that can generate 150 milliseconds with a clock of 6 megahertz, 16-bit na timer. So, yung number of cycles natin, 150 milliseconds times 6, that is 900,000 cycles. And 900,000 over yung maximum natin na period register na 65,000, that results to 14. Approximately 14. So, we use yung prescaler na 64. Okay? Using yung prescaler value na 64 with yung calculating yung period register natin, we get that, ayun, 150 milliseconds times 6 megahertz over 64 minus 1. We get 40,061.5. So, meron tayong konting problem dito. Hindi tayo pwedeng magsulat ng decimal numbers sa SFRs natin, di ba? So, meron tayong dalawang choice. Pwede nating ilagay sa period register is 14,061 or 14,062. Something to take note here, yung equivalent na time duration na to is either 149.999 milliseconds or 150.005 milliseconds. I think 0.995 yata dapat to. Exactly. And ano yung pipili natin? So, we have to go back at the question. Ano ba yung tinatanong sa atin? Or ano ba yung nire-require sa atin? So, a dash is at least, I guess yung keyword natin dito is at least 3 dot durations long. And ang 3 dot durations ay 150 milliseconds. So, ano yung period register value na at least 150 milliseconds? So, that would be the second one. So, 14,062. So, ang gagamitin natin na period register value is 14,062. So, yan. With this example, I guess we can add to our general solution flow. After natin makuha yung prescaler value to determine yung ating period register, we have to check if yung period register is fractional. You have to use your best judgment kung mag-over or under ba tayo doon sa target. Kasi, ayun, I think kahit gamitin mo yung prescaler na 256, hindi mo pa rin siya masasakto kasi mas less precise ang 256 sa 64. So, ayun, wala tayong choice. Hindi tayo pwedeng maging super exact. So, we just have to play it safe. And, ayun, check natin ano ba talaga yung nire-require sa atin if we want to go over or under. Okay, so those are our examples for period register and prescaler value calculations. You given yung ating clock frequencies and timer resolutions.